Activity 4. Finding the normal to a curved surface. Take a small piece of rubber. Fix some pins in a straight line on it. All the pins will be perpendicular to the surface of the foam. They are the normal for any incident ray at their point of fixation and help in obtaining the reflected ray. Now, bend the rubber inwards. The pins representing the normal at their respective points
So it's not coming.
Okay, so am I audible, right?
Yes, sir.
So now we have seen that just a one rubber, in that we have nails, but if we bend inside inwards, so what will happen? They will make one point, that is C, center of curvature. We'll discuss later. But that is actual the meaning what we have to take from here is there is converging. There is a converging. But if we bend outside, outwards, so what will happen? It will look like this, and the nail will look like this. Okay, they will diverge, but they appear to converge. There is an appearance. Backside their appearance to converge. Okay. Now, see, what is the meaning of spherical mirror? We are getting the word that is spherical mirror. Okay, so I'll let you know that. Before that, just come to this example. What is this, beta? Give the answer. What is this?
Circle.
Circle. In terms of physics, what we called it is a sphere.
Similar.
We called it is a sphere. But if we cut some part like this much, what if we cut? So will remains how much? So it will look like this much only, right? This is the cutted part of the sphere. So we call it is a spherical. The complete circle is sphere, and this is a part of the sphere. So we call it is a spherical. If I take the round circle mirror, sphere mirror, if I take, so this part we call spherical mirror. Understood better?
Yes.
Okay. So now don't write anything because of I'm recording this video. Later when I upload into the group, you just open the video, play it and copy your notes. Okay. No need to waste the time here while copying. So just now we understood that spherical mirror. Okay, but now if I take this spherical mirror and if I polished inside for reflecting the rays, polishing inside, and I'm coating outside. Have you seen any colors backside of mirror? When it breaks, you will get some green color, some blue color, sometime red, reddish color.
Sir.
Have you seen that colors?
Yes.
Yes. So that is a coating part. So we are coating outside. So we are coating outside. So this mirror, this spherical mirror, we called concave mirror. Which this mirror is called a concave mirror, where polishing inside and coating outside. But same mirror, if I polishing outside, polishing outside and coating inside, like this. So it will the rays will reflect outside. Okay, here inside. So this mirror we called convex mirror. Keep in the mind. Spherical mirror which is polishing inside, coated outside, that is a concave mirror. And a mirror, spherical mirror which is coated inside and polishing outside, that is a convex mirror. Okay. Now let's come to the some important points from here. So this is your spherical mirror. Okay. Now spherical mirror is the part of the circle. So in circle, center will come. Did you agree with this point?
Sphere.
From the sphere, the center will come. This is a part of the sphere, right? This is the part of the sphere, and this is the center of the this sphere. So now I'm taking one straight line here. Blue line. Very straight line I'm taking here. Okay, this straight line. What happening here? Straight line and this mirror, they are meeting at one point, right? This point
Pole.
we called pole. This point, which is the center of the sphere, we call it is the center of curvature. Center of curvature. And the line which we have taken, that is the principal axis. Clear beta these 3 points?
Yes, sir.
Okay. Now, in this shape, if you see the exact half of pole and center of curvature, exact half means, example, this is the exact half. So this point we called focus. What we called to this point? Focus. What we called beta? Focus.
Focus.
Okay. Now, then another point, that the distance between pole and focus. Focus, or we can say focal also. So the distance between pole and focus is known as focal length. Focal length means this distance. This focal, this principal axis, pole, center of curvature, focus, and this is the focal length. Is it clear, students?
Yes.
Yes, sir.
Okay, I'll explain you again. See, if a spherical mirror polishing inside and coating outside, आप घर के मिरर्स देखते हो ना, जिसमें आप नजर आते हो, इसके पीछे क्या होता है, कलर करा हुआ होता है, राइट? ग्रीन, sometimes reddish, sometimes bluish. So that is a coating part. Okay. So if it's spherical mirror polishing inside and coating outside, we call it is a concave mirror. But the same mirror which is polishing outside and coating inside, we call it is a convex mirror. Okay. And here in the third part, what we have taken a spherical mirror part and we have taken one straight line. Just close all the mics. So in this spherical mirror, we have one center, right? That is the center of the sphere, which is called a center of curvature. We have taken one straight line, which is passing through the center of curvature and a spherical mirror. That line we call principal axis. So the intersecting point of spherical mirror and pole, that is the intersecting point of spherical mirror and principal axis, that is known as pole. Okay. Now the exactly half of pole and center of curvature, that point is called a focus. Okay. And the distance between pole and focus, this pole and focus is called a focal length. Is it any doubt, beta? Till here?
Yes, sir.
Yes or no? Do you have any doubt, beta, till here? Please say loudly.
No, sir.
Okay, fine. So let's move with another one activity. So see in the first one what it has written in the figure 3. This is the figure 3. We have stuck 2 pins on the thermocol block. So this is the thermocol block and we have seen 2 things.
Sir, screen नहीं आ रही.
It is not looking.
Yes, sir.
How it is?
Yes, sir.
Are you able to see the screen?
No, sir. Yes, sir.
Okay. Now, are you able to see the screen?
Yes.
Yes, sir.
Yes.
Okay. So, in the figure 3, we have stuck 2 pins on a thermocol board. Okay, these 2 are the pins here. The pins are parallel to each other. Have you able to see the parallel pins? Yes. As we see in the figure, when a source of light is kept very near, we see the shadow diverging. So this light is very clear, right? It is very near to the thermocol base. So what happening? This rays, the reflection is diverging. The angle is diverging. Okay. The shadow of nails is diverging. See, it is diverging this side and it is diverging this side. Okay. Now we can say from the base of the pins, as we move the source away from the pins, the angle of diverging get reduced. So if we take this candle back side, so what will happening? This diverging is getting reduced. It is coming very straight. See, it is coming like this. Okay. So if we move the source far away, we will get a parallel shadow. So if we take a long back, we are getting the parallel shadow only. So, but as we move the candle away, the light intensity becomes low. Means if we take the light closer, the shadow will be get very dark. But if we take the candle away from that, the shadow will be get very blur. And yes, of course, they will show us straight parallel lines, but it is getting very blur. So that means to get a beam of parallel ray, the source should be at a long distance and it must be a sufficient intensity. तो इसका मतलब क्या होगा बेटा कि अगर हमें यहाँ पर पैरेलल लाइन चाहिए, बराबर से हमें उसका इमेज चाहिए, तो हमें क्या करना पड़ेगा, उसको एग्जैक्ट डिस्टेंस पे रखना पड़ेगा. ठीक है. The ray source should be at a long distance and it must be a sufficient intensity. और उसमें इतनी रोशनी होनी चाहिए कि वो बराबर से अपना इमेज बना सके. So where do we find one such source? So yes, we have one easily available source. You probably have guessed in it, the sun. See, sun is so far away, right? Sun हमारे से बहुत दूर है, लेकिन हमारा जो shadow आता है वो एकदम dark आता है, right? So the sun actually is our a very long distance and it is a very perfect distance. ठीक है. जो सन है वो बराबर दूरी पर है हमारे से, इसलिए हमारा जो इमेज शैडो जो पड़ता है वो क्या होता है, परफेक्टली आता है और वो एकदम क्लियर भी होता है. सो लेट अस डू एन एक्सपेरिमेंट विद द सन रेज एंड अ कॉन्केव मिरर. सो दिस एक्सपेरिमेंट वी विल डू इन